Hello, Honors Chemistry, and welcome to Update Flambé.
The Sizzle Girls.
Today, we will be making banana foster French toast.
With a twist.
It's an experiment! So, Kaylin, what's the first step in an experiment?
Well, Sonia, I'm glad you asked. The first step in an experiment is to form a hypothesis, which is a part of the scientific method.
Oh, interesting.
And the scientific method is a process for experimentation that is used to explore observations and answer questions.
So that's when you start with an inquiry and then do background research and come up with a hypothesis, right?
Yes. And then, next, you would design your experiment in the best way to answer your question.
Oh, and then once you get your results, you analyze them, and then the scientific method is used to produce the quality of the results from the observations, right?
Yes.
Oh, that's cool.
Now, since we are conducting our own experiment, we will be using the scientific method. So, our question is, which sugar will melt the fastest when making banana foster?
I think it's going to be the dark brown sugar. That's my hypothesis.
My hypothesis is light brown sugar.
Oh, really? Wow.
Then we did background research and decided to test 4 different sugars: cane sugar, light brown sugar, dark brown sugar, and powdered sugar. Next, we hypothesized which one will melt the fastest, as we just did. And then we designed an experiment and tested out at my house. The experiment involved making banana foster sauce and using a timer to time which one melted the fastest.
So now we just have to improve our experiment by conducting the trials and making sure that we keep each one of them consistent to decrease the amount of confounding variables, right?
Yes, and we also have to pick a control for our experiment, which is
the dark brown sugar, because that's the one we normally use when making banana foster.
That's true.
But after we conduct this experiment, we need to determine which one was the fastest and which one cooked the best, so that way we can tell all of our classmates the banana foster recipe, so that way they can make it on their own, and maybe even make it better. So, the actual first step in our process of making the banana foster French toast would be the French toast, which we'll get to right now.
For our experiment, we used cups, tablespoons, and teaspoons as our units of measurements. A unit of measurement is a previously agreed upon quantity used to report experimental measurements. You can measure length, weight, height, mass, and volume with units of measurements. Units are a vital part of chemistry because you need to be able to use a unit that is commonly accepted by other scientists around you. Grams, inches, and liters all need to have a common standard so that the measurements you use are the same as the ones your classmates use and other scientists. Some units of measurement can be subjective, like a dash of cinnamon, but most units are definite, like a cup of milk. It is also important to know certain units of measurement so that you can easily make unit conversions in recipes. For every ingredient in our French toast batter and banana foster sauce, we needed to measure an exact amount. For the batter, we used 4 eggs for the French toast batter, which in itself is a measurement. Units apply to our experiment because we used commonly accepted units of measurement along with subjective units. We used half a cup of rum and 1/4 cup of banana liquor for our experiment. We also used a dash of nutmeg for the French toast batter.
What is the bread, and how is it made? Well, it has a lot of chemistry behind it, including KMT, which is kinetic molecular theory. The kinetic molecular theory is a collection of several rules that describes the behavior of gases. This includes the volume, temperature, and pressure, which are all taken into account when observing and understanding the behavior of gases. So the KMT laws are based on gas laws. Gases are composed of a large number of particles that behave like hard, spherical objects in a state of constant random motion. These particles move in a straight line until they collide with another particle, or the walls of a container. These particles are much smaller than the distance between the particles, therefore most of the volume of a gas is empty space. There is no force of attraction between gas particles, or between the particles and the walls of the container. The average kinetic energy of a collection of gas particles depends on the temperature of the gas, and nothing else. So for our experiment, we made French toast. And obviously, French toast, you need bread. You can't have toast without bread. And so to make bread, you need yeast. Again, you can't have the bread without the yeast. Yeast is used in bread to activate a process known as fermentation. Carbon dioxide is one of the major gases responsible for leavening and baking. In bread making, the yeast organisms expel carbon dioxide as they feed off of the sugars. As carbon dioxide is formed, the dough rises. This is why the dough volume increases. The carbon dioxide expands and moves as the bread dough warms and bakes in the oven. As the temperature in the oven increases, the bread's volume increases and it rises. This is because of Charles' law. Charles' law states that the temperature and volume are directly proportional, meaning that when temperature increases, the gas increases as well. Therefore, since the temperature has increased, the molecules have more kinetic energy, so they move with a greater velocity. So, for this recipe, you need 2 eggs, a half a cup of heavy cream, a dash of nutmeg, and a teaspoon of vanilla. After that, you need to whisk all the ingredients together until it makes a batter. Once the batter is formed, you need to take your piece of bread and soak it in the batter until it is fully soaked. After this, you will take the bread from the bowl and transfer it into the pan. Whoa, Kaylin, is our French toast undergoing a chemical reaction?
As a matter of fact, it is.
Oh my gosh, what even is a chemical reaction?
I'm glad you asked. A chemical reaction is a process that involves the rearrangement of the molecular or ionic structures of a substance as opposed to a change in physical form or nuclear reactions. The signs of a chemical reaction are bubbling, color change, in this case, production of an odor, a good one, change in temperature, which this piece of bread has exhibited, and the formation of a precipitate. The reaction of the egg's browning is called the Maillard reaction. The Maillard reaction is a chemical reaction between the amino acids and a reducing sugars, usually requiring the addition of heat, which we have here. It is on 6. The Maillard reaction can also result in a change of odor for the toast. The browning of eggs on the toast in the saucepan is based on the amount of heat that is transferred from the heat underneath the pan into the bread. For the French toast, the first thing we must do is make the egg batter. Once that is done, we let the bread soak into the eggs and then put it into the pan with the heat on. While the toast is in the pan, it is undergoing a chemical reaction. While the eggs are cooking, it is browning on the outside.
So the Maillard reaction is the cause of what gives the French toast its color, its taste, its looks, everything?
Yes.
Wow, that's so interesting. So, moles and molar mass. Where do I begin? The molar mass is the mass of a given substance in grams divided by its amount of substance in moles. Moles is a standard specific scientific unit for measuring large quantities of very small entities. So the chemical formula for sugar is C12H22O11, resulting in a molar mass of 342.3 grams per mole. The molar mass of the other sugars would be the same as well because it's just pure cane sugar with molasses, which is just other sugar. So, the moles are needed to ensure that there can be a common standard for measuring atoms. Since we are using the 4 different types of sugar, all which have the same molar mass, we will be using our handy dandy balance with a half cup measuring unit, because that is what we plan, that is the amount of sugar we need in our bananas foster. And we will be using it to ensure that we have the same amount of sugar for each type of sugar. You know what else goes with moles and molar mass? Chemical composition. So the chemical composition of a pure substance corresponds to the relative amounts of the element that constitutes the substance itself. It can be expressed with a chemical formula such as an empirical or molecular formula. Chemical composition, for example, would be H2O, composed of 2 hydrogen atoms and 1 oxygen atom. So for us, our chemical composition of sugar is C12H22O11, meaning the sugar has 12 carbons, 22 hydrogens, and 11 oxygens. So C12H22O11 is the chemical formula for all the sugars. The dark brown and light brown sugar get its color from the distinctive presence of molasses. Molasses adds flavor to the sugar and also ensures that the sugar is softer and lighter to use. So, Kaylin, what's the main ingredient in our experiment and in Bananas Foster?
Well, Sonia, the main ingredient is sugar.
Like dark brown, light brown, and granulated? But where's the powdered?
Boom!
So, like, how does chemistry even apply to sugar? Like, it's sugar.
Well, sugar has chemical and physical properties and changes.
I know what a physical property is.
Really, what is it?
A physical property is an aspect of the matter that can be observed or measured without changing its chemical composition. And a physical change is a change affecting the form of a chemical substance, but not the chemical composition. But what's a chemical property and change?
A chemical property may only be observed by changing the chemical identity of a substance.
Oh.
And a chemical change is a process where one or more substances are altered into one or more new and different substances. This process happens by bonds breaking and or forming new bonds.
So, the chemical and physical properties of a compound differ.
Yes.
Obviously, the physical properties would be the weight, visual characteristics, color, etc. But the chemical properties can only be observed after a chemical reaction. So, the chemical properties would include toxicity, reactivity, flammability, among many other things.
Correct. So, the physical properties of sugar, for cane sugar, it's that the granules are larger and white. For light brown sugar, there are even smaller granules than cane sugar, and light brown sugar has molasses, which is signified by its darker color than white sugar, and it's lighter color than dark brown sugar.
It's also very easily packed.
For dark brown sugar, it has more molasses than light brown sugar because its color is even darker and also easily packed into its small granules.
And then powdered sugar, which is itty-bitty granules of ground up cane sugar.
Depending on the type of powdered sugar you have, it is 10 times, you can't see it, 10 times smaller than granulated sugar.
So, since these chemical properties include flammability, toxicity, and reactivity, the chemical changes occur when a substance combines with another to form a new substance, undergoing a chemical reaction. These reactions are irreversible processes that include chemical synthesis, chemical decomposition. So one of the chemical properties for sugar is its chemical formula. Since we do not know the chemical formula for molasses, we can't get the exact one for dark brown sugar and light brown sugar, but we know the chemical formula for table sugar, which is also cane sugar. The chemical formula is C12H22O11. It has a molar mass of 342.30 grams per mole, and sucrose with molasses and brown sugar and dark brown sugar also contain 3.5% to 6.5% molasses. This applies to our experiment because we are changing the sugar in each experiment, which makes the sugar our independent variable. Because each sugar has different chemical and physical properties, the experimental values will obviously differ.
Exposure to heat initially melts the sugar into a syrup. This is the breakdown of the sugars into fructose and glucose, and is marked by the smell it produces. Further decomposition results in a color change of cane sugar from white to yellow to brown.
Place the 130.67 grams of sugar into the pan along with 2 tablespoons of butter, half a cup of rum, and a tablespoon of banana liqueur. Once everything is in the pan, let the alcohol boil on the stove for a little bit and then flambe the alcohol. Repeat these steps for all 4 types of the sugar.
As you can see by the formation of bubbles right here, the rum, banana liquor, and butter are all starting to reach their boiling point. A boiling point is the temperature at which a liquid boils and turns into vapor. IMFs, which are intermolecular forces, are forces that hold 2 molecules together. Boiling at the particle level is when an increase in heat causes the atoms or molecules to move faster than they were before. The increased movement causes the molecules to crash into each other and into the sides of the container that they are in. If some molecules move fast enough, they escape from the larger pool of molecules and escape to produce steam. Since the boiling point of rum is 173 degrees Fahrenheit, rum has weaker intermolecular forces. By boiling the rum, the alcohol is evaporated off because alcohol boils at a temperature of 133 degrees, which is lower than that of water's, which is 212 degrees Fahrenheit. Therefore, it reaches the boiling point and evaporates faster than water. For our experiment, we are adding 1 cup of rum to the pan once everything else is added. Then, we light the rum on fire to flambe the alcohol off. We will let the alcohol and fire rest until the fire goes away, itself signifying that the alcohol has cooked off. The flash point of a compound is the lowest temperature that it will ignite. This means that at the temperature, the molecules will keep burning even after the ignition source is removed. After the alcohol is burned off, the rest of the remaining ingredients in rum, such as molasses, sugarcane juice, and water, will remain in the syrup. We come to our final test, let's talk about the heat of solution. The heat of solution is the heat evolved or absorbed when a substance dissolves. The sugar here is decomposing. The rum solution contains 38% alcohol. It is made with fermented sugarcane juice, sugarcane syrup, and sugarcane molasses, and other sugarcane byproducts. The maximum amount of alcohol that rum can contain is around 85%, but the one we are using contains 38%. When boiling off the alcohol, the rum is absorbing all of the heat from the pan, along with the heat from the flambé to cook off the alcohol quickly. To cook off all of the alcohol we used in our experiment, we took advantage of the lower boiling point in 135 degrees Fahrenheit and flambéed the alcohol at its lower boiling point. Since we flambéed the alcohol and left it in the pan, the rum absorbed the heat quicker, so it boiled off faster. To minimize confounding factors, we kept all of the factors in the experiment the same, which is 2 ounces of butter, a half cup of rum, a tablespoon of banana liquor, and 130.67 grams of sugar. So the concentration in the entire solution should be the same for each type of sugar tested. A concentration solution is one containing large amounts of solute relative to the amount of solvent. The solute is the liquid in which the solvent is being dissolved. When there is a larger amount of solute relative to the solvent, then the concentration of the solution is higher. Rum is mainly made up of water. For our experiment, we used Bacardi dark rum. The rum base is made with 6.7 gallons of water, 1 gallon of molasses, and almost 1 gallon of sugar. Then, while making the actual rum, 5.5 more gallons of water is added to the solution. More water is added later to distill the rum produced during the process. Without the dilution, the rum could be up to 95% alcohol, which is too toxic for consumption. The solvent in the rum is the water, and the solute is the molasses and sugar. For distilleries to be able to make rum properly, they need to make sure they do not use too much sugar, or the rum will be too sweet, or the sugar could burn. They also need to make sure that they use the right amount of water so that the sugar to water ratio is not disturbed.